Hi everyone, welcome back. In this video, I'm going to go through an introduction of dynamic memory allocation in C++. So you can see here in my virtual machine, I've got a very short C++ file open called dynamic memory main. Okay, so this file has a main function with some comments in it, and then it's got a print array function and prototype up here that I wrote in a previous video. All right, so for dynamic memory allocation, we need to have a good working knowledge of pointers and local variables. Okay, that's kind of the foundation for moving to dynamic memory allocation. So that's what these comments are for here. So let's review what a pointer is. A pointer is a variable that stores as its contents the memory address of another variable, okay? Or it just stores the memory address. Okay, I like to put the of another variable on there in the beginning because I think it really helps people learn what pointers are. But then we learned that an array is actually a pointer, so we've been working with pointers for a while, right? An array stores the memory address of the first element of the array. Okay, so the first element of the array isn't actually a variable because it doesn't have a name, right? But it is a memory cell. It is a region of memory that stores contents. So if we have the memory address of some memory cell, then we store that memory address. We have a pointer, right? So a pointer is a variable that stores as its contents the memory address of another variable or some memory cell. All right, so arrays are pointers. And then the last kind of working bit of knowledge that I want to make sure that we all have before we start dynamic memory allocation is what is a local variable? So a local variable is a variable that's defined inside of a function. So if we look at print array, I've got 1, 2, 3 local variables. ARR and size are parameters. They're local variables. And I is a local variable. If I had a variable, say, defined like here on line 4, that would be outside of a function body, so it would be a global variable, okay? So we're talking about local variables right now. So we know that when a function exits, the local variables are deallocated, okay? We can't access them anymore. Now we're going to learn a little bit more about why that is. So I'm on my lines 11 and 12 here. Local variables are allocated in a region of memory called the stack. So when a function exits, the stack area that was used by the function is deallocated. So if we have a region of memory called the stack, we might have another region of memory where when a function exits, that region is not deallocated. And that brings us to dynamic memory allocation, okay? All right. Pointers and local variables. One thing I want to note is never return the memory address of a local variable. Okay? If we do that, we're essentially returning a memory address that points to or refers to memory that's just been deallocated, right? So we don't want to do that. We don't want to return the memory address of any memory that exists in the stack. What we want to do is we want to return the memory address of memory that exists in the heap. So kind of the goal of dynamic memory is to return the memory address of memory in the heap. Okay, so the heap area of memory is not deallocated when a function exits. The key here is it's deallocated when the programmer, I'll say you, the programmer, deallocated. And this is also known as freeing memory. Okay, deallocate, free. Okay, so it's a very manual process. If we're going to declare a variable that stores the memory address of an area in the heap, okay, and that area isn't automatically deallocated when a function exits, that means the responsibility is on us, the programmer, to later deallocate that memory when we're done using it. It's a little bit like opening a file, right? When we open a file, it's our responsibility as a programmer to remember to close it. All right, so let's take a look at an example, okay? So let's say we want a function to allocate memory for an array of random numbers, okay? We want the function to allocate the memory, okay? We could write this code now if we had the calling code allocate the memory and then pass in the memory address of that contiguously allocated memory that exists on the stack for the calling code, right? And then we know that another function's called, it has local variables, it's going to update the array, its local variables are going to be deallocated, but that array and its changes are going to persist because it's on the stack in a function, this calling code, that hasn't returned yet, okay, hasn't exited. Okay, so we could do that, right? We could declare an array in main, pass it into a function, have that function modify it because it's passed by reference. Okay, we could do that. But this time I say we want the function to allocate the memory, okay? So I'm not going to allocate the memory in main, in the calling code. All right, so we use the new and delete keywords to dynamically allocate memory. So we will use these. We will use these in the function to allocate memory on the heap. Okay, so when you think of dynamically allocated memory, think of it existing in the heap. Okay, the heap is different than the stack. That memory is not deallocated when the function returns. All right, so I'm going to need a pointer to this memory that's going to be dynamically allocated by this function. Okay, good practice. I'll initialize it to null or to null pointer. All right, next I'm going to call the function. So let's call it create random array. Okay, it's going to actually create and fill it, and all I have to do is pass in the size, right? I'm not going to pass in the memory for it to fill because this function is going to create and fill. This function is going to return the memory address of that array allocated dynamically on the heap. So I do need to have an assignment here where I save that memory address from the heap in rand arr. And now you can see why I kept this print array function, because to check our work, we'll pass rand array into print array to take a look at it, okay? And I'll make a little note here. We need to free, aka deallocate, rand arr when we are done with it, okay? So we'll do that after we write the function, okay? Let's see new first, and then we're gonna come back here and see delete. All right, so the return type of create random array is going to be an int pointer, right? It's going to be an array of integers. So it's going to return the memory address of the first integer. Okay, so the memory address of an integer is a pointer to an int. All right, so I'll have my I variable that's going to drive my loop. I'm also going to have a pointer called arr, okay, just a little more general name here, which is going to be assigned that dynamically allocated array on the heap using the new keyword. So I'm going to write new int of size, okay? So we know this is our array notation, right? We pass in our size descriptor. Here's the type of our element. And here's that new keyword called new, okay? So this is going to be on the heap. Now I'm going to go through, and I'm going to initialize all of the elements of the memory address pointed to by arr to be random. Just mod by size. I don't really care too much about what I fill up the array with. All right, and then I'm going to return arr, okay? So here I'm returning a memory address of memory that was allocated in this function, okay? But it's not memory address of a local variable. It doesn't exist on the stack. It exists on the heap because I dynamically allocated it using the new keyword, okay? So this is pretty cool too because I can specify the size when I know it, right? This is parameterized. It's not always fixed in size. I can declare as much or as little memory as I need depending on the value of this parameter. All right, so I'm gonna make one more note here. I'm gonna say it is the calling code's responsibility to free this memory, Okay, this function allocates, it doesn't deallocate. Okay, so this memory is going to persist until our calling code frees it. This is important because if we ever forget to deallocate or free memory, we have something called a memory leak in our program, and it can greatly slow it down. Okay, so anytime we use the new keyword, we want to remember at some point in our program, when we're done with this memory, we need to use the delete keyword in order to free it. Okay, it's not automatically going to happen like variables or memory that's allocated in the stack area. Okay, so we could compile and run this, but I'd have a memory leak, right? So I'll make a note. Memory leak unless we free ran ARR's memory on the heap. Okay, so I'll go ahead and run it. I'll just make sure that it compiles. And then we'll go ahead and we'll delete it. So I'm going to need a prototype real quick. And then let's see if it compiles. Okay, oh, yep, I got to pass in the size here. Easy enough to forget and easy enough to add. Wonderful. All right, so I'm going to run this. Okay, and here's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 random numbers in the range 0 through 9, right? Because I'm modding by the size. Perfect. Okay, so this is dynamically allocated, okay? But it functions the exact same way. The only difference is it's allocated in a region of memory that's going to persist until we explicitly free it, okay? So let's go back to all my notes here, right? We don't want to forget to free it. So the code to free or deallocate this array is delete array called rand array, okay? And then it's always good practice to set the pointer to null or to null PTR. Null is kind of the C style of saying a pointer isn't valid, it doesn't point to anything. Null PTR is kind of the C++ style of doing that. So ran ARR is assigned null, okay? So just good practice to do that. Because deleting or freeing the memory doesn't actually change the contents of ran ARR to be 0 or to be invalid, okay? So it still stores a memory address, but this is gonna completely wipe out the contents, and now we don't even have that memory address anymore, because if we were to try and use it, we would get unpredictable behavior, including crashing our program, because we just freed that memory. All right, so I'm gonna run this. It's gonna run exactly the same, except for now we don't have a memory leak, okay? Last time I ran it, we did have a memory leak because we weren't freeing our memory that was dynamically allocated, but now we are, and we are not having a memory leak anymore. All right, so that's kind of a high-level overview, a quick crash course in dynamic memory allocation. The keys to remember are stack versus heap, okay? Local variables allocated on the stack. That memory is deallocated when the function exits, so we don't have to manually deallocate it. But if we want that memory to persist for some reason, right, like this function, right, it creates and fills an array, and we want to be able to use that array in the calling code, okay, then we're going to have to allocate that memory dynamically on the heap using the new keyword, and now we have a responsibility as a programmer. In order to not have any memory leaks, we have to free or deallocate that memory from the heap when we're done with it using the delete keyword. Okay, so that's what we did up here. All right, well, thank you so much for watching the video. Feel free to post any questions or comments you have in the comments for this video. Thank you again.